set some ground rules here. What we're going to be doing today is we're going to be giving you an introduction to Carel. We're going to talk a little bit about humidification basics. We're going to talk about the products that Carel has for humidification and their applications. We're going to talk a little about an online product selection area, and then, of course, who to contact for further questions. Just some web meeting etiquette. Everybody's on mute right now, so we won't have to worry about your cell phones going off or people calling in to talk to you. If you do have a question, please use your chat feature. That should be one of the boxes on the right-hand side. We'll stop during the presentation. We'll kind of monitor the questions as we go along. If there's questions on a slide that's coming up, I probably won't answer it. I'll wait till the slide comes up. And then we'll be on at the end for a little bit just to answer any questions that do come up. Doug, do you want to tell them a little bit about Carel and what kind of company they are?
Absolutely. As you can see on the slide, Carel was established in 1973 in Padova, Italy. Started out as a controls company. We currently manufacture HVAC controls, refrigeration controls, and humidification product. All of our control products are currently manufactured in our Italian manufacturing facility. Our humidification products, the raw materials are basically put together in Pavada and then shipped to the United States and then assembled at our United States office in Mannheim, Pennsylvania. 100% of the product in the humidification lineup is assembled at our plant, so we do qualify for the Build America Act. As you can see, we also have manufacturing facilities in Suzhou, China, Pavada, Italy, Mannheim, Pennsylvania, and Sao Paulo, Brazil. And we also have sales offices in, I believe, 25 additional countries as well. That being said, we are continually growing and adding sales facilities as we go along. We are constantly doing R&D on our product categories, so there's constant changes to our production lineup in both refrigeration, air conditioning, and humidification. Carel is dedicated to staying up to date with today's technology.
Continuous R&D.
I just got basically ahead of the slide.
Okay.
As the slide shows, we do have testing facilities in Mannheim, or excuse me, both Mannheim and Pavada, Italy. This is showing our testing facility in Pavada, Italy. To the right, it's actually showing some of our compact steam, light commercial and residential humidifiers, and to the left is showing some of our steam humidifiers.
And if I'm not mistaken, Doug, Carel, one of their strong points is the controls that they have.
Absolutely. The majority of our humidification products have our controls integrated with them, once again, to provide state-of-the-art control.
All right, a little bit about humidification basics here. If somebody's new to humidity and some of the terms, we're going to talk about that. We're going to go over 3 basic product types that they have and where applications that you should be using some of them are, and then some sizing and selection software that's online. So we'll be covering all those here in the next few minutes. A little bit about the term relative humidity. We always use the term relative humidity all the time, but relative humidity is relative to the air around it. You can see if the water vapor is exactly equal to the air surrounding it, it's at 100% relative humidity, like rain or a steam room. 52% relative humidity the water vapor occupies 52% of the mass volume of the air. And as you go down in relative humidity, as the air expands, the relative humidity, the relative water vapor in the air goes down. Like when you are out in Phoenix, the water vapor or the relative humidity is a very small amount. So if you keep the same water vapor in the air, as the air is heated, the mass of the air gets larger, and the relative humidity of that water vapor in the air gets less and less and less. Why do we need humidity? Obviously for creature comfort, hospitals, operating rooms, theaters. Humid air makes us feel warmer. You probably have seen it in your home. If you have humidified air, or if you run a humidifier, you can set the thermostat down by 2 or 3 degrees and save some energy. And of course, dry skin, allergies, lung irritations, all that is caused by low humidity, wood cracking, things like that. Products need the correct amount of humidity too. Electronics, of course, you can't have a lot of high static electricity. Textiles and paper mills. One of Willis Carrier's first jobs was a paper plant where they couldn't get the color on the comics to fit within the lines because the paper would expand and contract depending on the humidity. So they wanted him to control the humidity in an application so that they can keep the color inside the lines for their comic pages. Preservation for antique storage museums, food, those are all just common areas where we need humidity. So everything really needs humidity. This slide's been around for a long time, but this is actually health, and you can see dry nasal passages, dust mites, mold, even certain bugs like mosquitoes. I read an article in the paper that the West Nile virus, those mosquitoes aren't going to be as prevalent this year because they like dry conditions, but we will have a lot more regular mosquitoes because they do like wet conditions. But you see between 40 and 60% is where you want to be for humidity. Static electricity, you want to be a little bit above 30%. So all these things go to provide health for yourself and the things in your room. There's 2 ways that people can humidify. The general utilization of steam is the isothermal. That's what we're going to basically talk about today. The other way of steam is the adiabatic. That's where you evaporate steam into the air, kind of like a paint can. If you've ever had a paint can, you can feel it getting cold as you spray it. That removes heat it adds heat to the air. So you have to be aware of that. But the isothermal, the first method, it uses hot water, and as long as it stays relatively small to the volume of the air, it's okay. When you get into applications like steam, steam rooms and things like that, then that will be a little bit more. You have to watch out for the heat in the air. This is a little bit about the psychometrics. If you have the temperature will stay the same as long as the vapor mass is less than the air mass. Once it gets up to a certain point, it gets up to that saturation curve, then the room gets hot. But you can see you can go from 10% to 60% relative humidity, and it's not going to really add a lot of heat to the atmosphere, and not until you reach the saturation point. Now the adiabatic, you can see that it sucks heat from the from the surrounding air, so that would be absorbing heat. Like I said, that metaphor of holding a paint can, if you hold it long enough, you can feel it getting cold. It's absorbing the heat from your hand. First product they have is their Humisteam. It's an electrode version. And as you can see here, it uses 2 electrodes. these electrodes here, where electricity passes through the water, it uses electricity to add energy to the water to boil it and create steam. As it says down here, the voltage is applied to produce a steam. It's proportional to the electrical current that you put through the water, and the current is proportional to the level of water. So it does track how much water is in the canister, and then when the canister gets full, it puts more electricity in there to boil the water. You can see that their UE series, the Humisteam, ranges from 3 pounds per hour to 286 pounds per hour, so it can be used in some residential applications. This is a little bit of a diagram here to show you the cycle. It fills up. It fills up. The electricity is increased as it fills up. The electricity goes down as the water goes down. And then when it shuts off, there's a drain cycle there too. So it does drain to remove any impurities that is in the canister.
This particular unit is also fully modulating. It'll modulate down to 20% of its total capacity. So if you look at the, you see 3 tubes to the right of the canister. The center tube is basically showing the fill line. So there's a little like fill tube which determines the level of water in the tank. The amount of water in the tank is directly related to the amount of humidity being presented into the space at the time. So as you can see, if the canister is filled at 25%, then it's producing 25% of the humidity. If it's filled 100% towards the top, then it's producing 100% of the steam humidity. The other feature of this unit will give you 3%, or excuse me, I'm sorry, 5% plus or minus accuracy on humidity. So at any time it'll be 5% either greater than or less than the call for humidity in the room at the time.
And I'd like to point out that this does not use or does not need water who's been through a reverse osmosis process. You can use just tap water because it does take a certain amount of particulates in the water to transfer the electricity from one plate to the other. They do have a version that if you have very clean or softened water that you can use, you can add an accessory to it that we'll look at a little bit later on.
To Dave's point, not only you don't have to use reverse osmosis or DI water, but you can't. The other side of that coin is since you are using the conductivity of the water to produce the steam, purifying it would take the minerals out of the water that are necessary for the system to produce steam.
If you have questions, I'd like to repeat it again. If you have questions, please type them in the chat box that you have on your screen. That's the only way we can see questions. If you think of something afterwards, one of the last slides is my email. You can copy that down, and you can also email me something after the presentation's over, and if you think of it. This presentation will also be recorded too. When we send out a thank you, we'll send you out the link to see it. A little bit about the controls. Doug, you want to take this?
Sure. Once again, since we are a controls manufacturer as well, we integrate the controls into our product. This particular product, our Humisteam, utilizes our Peco controller plus our digital display panel. The digital display panel gives you a real-time readout of exactly what's going on with the humidifier. The humidifier has a built-in 24-hour flush and fill cycle. depending on the water quality, it is very easy to change the programming to either be a 48 or 120 hours in between flush and fill cycle, or even shorten it to 12 hours depending on the overall water quality. The other part of this, once again, because we are using our Peco controller, this will also work very well with most system building management programs. So it'll work with BACnet, lawn, and Modbus. It can be both controlled and read by those systems.
Somebody did have a question about replacing the canister. Yes, you have to replace the canister, probably about every 2,500 hours of run time. So the canister is replaced. It's not cleaned out.
Again, the amount of time in between changing the canister is going to depend a lot on overall water quality. The lot harder water that is in a particular system, the more frequent the canister is going to have to be changed. In those kind of scenarios, you can help lengthen the life of the canister a little bit by adding a number 5 or number 1 micron filter in front of the supply line leading into the humidifier. Which one you use will depend on the actual hardness of the water. And one thing you can do, if you are not 100% sure what kind of quality the water is, you can approach the local village water supply and ask them to provide you with a water quality printout. That can then be turned in to Dave, and he can email that to us, and we can analyze it and see where that fits into our basic range of operation.
Here you can see on the UE model the range of steam that it produces in pounds per hour from 3.3 all the way up to 286. So it can be used in quite a few commercial applications. Well, obviously the larger ones take a little bit higher voltage. Summary for the UE, the electrode humidifiers, it uses regular tap water. The output range is 20 to 100%, so it has a wide range, so it can adapt to different humidity conditions. You can do a duct or blower mount. We'll talk about that a little bit later on as far as the wand that goes in the duct. And there are 570 volt models available. The replacement cylinder reduces the planned maintenance time and cost. Like Doug said, that depends on the quality of the water. It's very competitively priced, and it meets ETL and CUL requirements. Okay. Any questions on there, on the UE model? Okay. We'll move. All right. The Heatersteam model is the UR model, and this is actually a heater element. This prefers deionized over reverse osmosis water because this uses an element, and harder water will precipitate on the element itself. It has internal probes to monitor any kind of foam production. Foam production would occur if there was matter in the water. When it was boiled, it could develop a foam, so the foam production is monitored. And now this is also a removable and cleanable and reusable tank too. So this one takes a little bit more maintenance, but it's not quite as costly for the tank. This one is more precise. So you can get not to plus or minus 5%, but you can get more precise with the humidity ranges. So if you have an application that has more precise needs for humidity, this would be your model.
It actually will give you 2% plus or minus RH, so it'll give you a lot tighter control. The last unit we talked about, we said it would modulate down to 20% of its total capacity. This one used to modulate down to 10%. We have upgraded some of the computer chips on the unit, and now it is 100% modulating. It'll modulate down to 0 all the way up to 100% of its total capacity. So it's a fully modulating unit. And as Dave said, since you can use reverse osmosis or DI water with this unit, it is pre-programmed at the factory like our other unit for a 24-hour flush and fill cycle automatically built into it. With the use of DI or reverse osmosis water, you can program that out as much as 6 months before it even needs a flush and fill cycle. That's how clean it runs. And that being said, the use of DI or reverse osmosis is also highly recommended, once again, like Dave said, because it does make it a lot easier to clean these units, and it extremely extends the life of the elements.
And just there's an option that they have is a drain tempering kit if you have PVC drain. One of the options is there because of some of the building codes you need to temper the water, so that is an option with this. You can see that it goes from 4 pounds to about 135 pounds per hour, so the capacity is smaller, but still within the range of many commercial applications.
Now the other side of it, this unit still uses a little bit older controller, so it's analog instead of digital, so it gives you a series of numbers that you'd read, and then you go to the user manual and identify what the settings are based on that. That being said, at this time, this particular unit can be read by Modbus only, but cannot be controlled by Modbus or any other protocol.
Here we show you the different ranges, the different voltages. Obviously, the larger units require higher voltages. So this just gives you a little bit of an idea of the capacity, the power draw that you would have with the different units. Quick repeat here. Output range is 10 to 100, or no, 0 to 100 right here. This humidifier is good for much more precision accuracy, plus or minus 2%, but tap water or deionized water is recommended for this. We had a question about what is CUL. That's the Canadian Underwriters Laboratory. So thank you for that question. The last, the one with the isothermal systems is their gas-fired. They're UG, used for gas. And as you can see, this is 100 to 400 pounds per hour, so this is a lot higher capacity, 92 to 95% burner efficiency, and 100% steam is delivered to the output. So this is the big boy here. Deionized or reverse osmosis water is required, and also because of the hot water that's coming out of the unit, drain tempering required for most building codes. It has a fully modulating gas valve, and it modulates down to 25%. It mixes the gas and the air, and the blower modulates down to 25%. On the larger unit, the 400 pounds per hour, that modulates down to 12.5%. So this is the large guy of the system here, and it handles most applications, most commercial applications.
Can use both natural and propane gas, and needs no additional accessories. It's just a simple switch inside the unit itself. As you can see, once again, it does use our Peco control panel as our Humisteam product did. And so therefore, we'll work with all of the building maintenance systems again, lawn, backnet, and Modbus, and can be both controlled and read by those systems. As Dave said, this is fully modulating. We'll modulate down to 25% of its total capacity on the 100 and 200 pound cabinets. And for the 400 pound cabinet, it has 2 tanks, so it'll modulate down to 12.5 of the total capacity. The RH control on this unit is about 3 to 3.5 plus or minus RH. One of the strongest features of this unit is the fact that it runs at 92 to 95% efficiency. That being said, along with the fact that gas is still quite a bit cheaper to run than electricity, this unit will cost your customers approximately 30% less in energy costs to run than either of the 2 electric products.
All right. So those are just kind of what we talked about here. High efficiency burner, Niflon coated heat exchangers, which are removable, indoor or mechanical room applications, and works on natural or propane gas with no orifice change. Okay, a little bit about the ultimate SAM, the short absorption module. This is how it gets into the space. And there are several unique things in this that we're going to talk about. There's a single pipe version for smaller amounts of air into the space, a multiple pipe version with a bottom feed, and then a multiple pipe version with a top feed. Now this works with the steam in the building. All right, it utilizes pressurized steam from a centralized system. So this is just a duct-mounted dispersion tube, but it is kind of unique, and we wanted to go over it.
Well, like Dave said, this is works on a pressurized system, so it'll work with 0 to 60 psi. But this is also now an atmospheric short absorption manifold as well. So this manifold will work with all 3 of the steam units that we have as well. So it'll work with the Humisteam, it'll work with the Heatersteam, and it'll also work with the gas steam as short absorption manifold systems. The regular distribution method for all 3 of those cabinets would be a single tube distributor, which would use a single hose going from the unit to a single distributor tube, which would go either inside the ductwork or the air handler itself. In areas where you need extreme short absorption, 6 inches or less, then you would go over and utilize a full manifold ultimate SAM system with that. As you can see on this screen that we have here, we have a single manifold tube as shown in the center picture with a basically a stainless steel insulator around the outside of that. What that stainless steel insulator does, a lot of our competitors offer a jacketed manifold that has 2 steam inlets. One steam inlet going inside the jacket, which surrounds the outside of the manifold, and one that goes up the center of the tube, which produces the steam. In our case, we just have one steam distribution up the center of the manifold, and then the stainless steel insulator on the outside. Basically, what the stainless steel insulator does is the same thing their jacket does. It allows the manifold to heat up quickly and allow the steam not to condensate out. It also, because of that air cushion that's there, keeps them from heating up too much. So it keeps it from overheating. From there, we use a 6 nozzle strip of material called a PPS Riton material, which is press fit onto the manifold at the factory. The reason we do 6 nozzle strip is for strength. The Riton is a very strong material. It will withstand up to 428 degrees Fahrenheit and will withstand the majority of chemicals that would be put into a boiler system. From there, if you look at the far left picture, you can see that the nozzles themselves protrude into the wall of the manifold. Okay, So now only sediment and condensate are going to run alongside the inside wall, and just a nice clean dry steam is going to make it to the nozzle itself. So you're going to have very little clogging or spitting, very little maintenance, and very clean dry steam produced from this product.
This allows that short absorption distance to be used. So
well, the combination of the heat inside the tube, and then since it is a manifold system with multiple tubes, those two combinations give it that short absorption.
So if you have something up in a ductwork in a ceiling with a fire damper, just maybe a foot or two down the airway length, this short absorption module is something that you want to consider.
Absolutely.
And this is just a picture of what it looks like, and you can see that the steam range is anywhere from 10 to 2,200 pounds per hour. You can see certain configurations for a single pipe system, multi-pipe system with a bottom feed, and a multi-pipe system for a top feed. Okay, I'm going to check questions here. Okay, we're all okay. This is a little bit about how it would be installed. This dispersion tube here is what you would get normally with the unit if it's not the short.
The distribution tube to the left basically would be for the electrode, the element, or the gas unit. It would be a single distributor tube. It comes in lengths of anywhere from 12 inches on up to 84 inches, depending on the duct or air handler size, and also a combination of the load requirements. And then off to the right, you can see for room distribution, either a top mount blower, or to the right of that, a remote mount blower, which will blow directly into the space. All of our units, the gas and the two electric units, can be fitted with the blower packs as well. The two electric units on 4 smaller size cabinets can use the top mount blower pack, and then the larger electric units along with the gas unit would use the top mount blower pack. And again, that's for blowing the humidity directly into the space itself. And then for extremely small duct applications and smaller loads, not pictured here, we have a little nozzle, jet stream nozzle, that if you look over to the distributor tube to the far left, if you look at where it shows figure number 3, the jet stream distributor nozzle would basically be just the size of that, and then have just a very small nozzle that would blow into a duct that's either 12 inches or smaller. So we have accommodations to fit most sizes that you would have. The next thing to consider is the length of distribution hose from the cabinet to the nozzle itself. Dave tells me I'm getting ahead of myself, so right. I'll let him get to the next couple screens first.
All right, one thing I want to point out, and these diagrams are from the installation manuals, it does have to be pitched backwards, so the condensate does come backwards. So that's one important thing that has to be pitched. It's just a few degrees, but it does have to be pitched. So when you're installing it, be careful of that. All right, here's a little bit about the 10-foot of steam hose, compromises capacity. 10 feet is about the maximum you'd want to have.
It's basically the most efficient. Our engineers and our competitors as well have pretty much determined that 10 feet will give you the optimum performance from the cabinet itself to the distribution hose. Once you start going further than 10 feet, you start compromising steam distribution to condensate. Now, it can be done, but as you go further out, you do start compromising performance. We recommend going no further than 20 feet from the cabinet, utilizing the hose that we distribute with it, the standard steam hose. And then from that 20 feet, as you can see in the second figure on top to the right, they're showing at the 10-foot mark, you would put a P-trap in the line there as well in the condensate. Well, they're actually showing it on the condensate line itself right there. But on a 20-foot run, you would put an additional condensate line in the distribution hose itself as well to help keep from any condensate building up inside that tube. The other thing that you can see is they're showing a constant incline from the cabinet to the duct or air handler so that any condensate would flow backwards. And even steam distribution forwards because steam rises.
Correct. Right. And obviously no dips or humps in the steam line because that would cause a trap that water could be could condensate in and then the steam can't get up to the ductwork.
Correct. And gradual bends as well, no 90 degrees.
All right, we'd like to show you a couple of selection tools online, and it's at humidifynow.com. We're going to jump over to that. Just wanted to check and see if there's any questions. I think we're all okay there. All right, we're going to jump over to Humidify Now. And this is humidify.now, and this is the load calculation up here. If you just sign in, there's a sign in on the home screen that just says click here to log in as a guest. You're welcome to do that. You can build, you can check the loads, how much pounds per hour that you need, and you can also build your application with all the model numbers so that you can either put this on the specifications or you can just send it to your TEC representative and he can price it out. But we'll take a quick selection here of the outside air design at -10, outside air relative humidity at maybe 20%, space design, let's pick 72, and space design relative humidity 50. And of course, we might just call this test unit. And the room, let's just put a short room, 20 by 20 by 8 feet. And infiltration average, and we click on calculate humidification load. Nope, it logged us out.
It timed out, yep.
All right, you can see it log in. There we go. So test unit, and -10 on the outside, maybe 20% outside air, space design at 72, and space design relative humidity at 50. Let's just do a small room, 20 by 20 by 8 feet. Average infiltration, and we'll calculate the humidification load. And there it is, about 4 pounds per hour. If we're in the ductwork, let's say it's 400 CFM, and maybe have 10% outside air. And we can recalculate it again, and there's just 1 pound of duct load. Now, if you want to have an economizer, you can put that in here if you want to calculate what that load is. But at this point, you can either add this to your calculation history or select a matching humidifier. I'm going to show one more thing here below in the bottom of the screen. It will also calculate your horizontal distributor evaporator distance. So this is how far down the air takes to evaporate.
Correct.
And we can put in 50% here, leaving relatively, probably going to be 50-50. Let's make it a little longer, maybe make it tube length, duct temperature. Let's maybe make it 95. And it's going to be evaporated immediately. All right, so we'll go select a matching humidifier. these are humidifiers that you see that has the 4 pounds per hour. So I can either take the Humisteam, which has the electrodes, I can take my Heatersteam, which has the electric coils, or I can even build it with my gas. So let's just build it, since this is a small one, with the Humisteam. And project name, test unit. Now it's going to ask you the voltage and conductivity, and you see you have standard ranges of disposable cylinders, and these special low ranges of disposable cylinders are for water that's purified water or softened water.
Lower conductivity.
Lower conductivity, thank you. I'm just going to take a small one since this is a very small unit. And here it's where you specify the distribution type. If it's, like Doug said on an earlier slide, if the duct is less than 12 inches, it's just a little nozzle that sprays into the ductwork. But if it's larger, you can have different larger sizes. And here's the remote blower or duct-style blower. So let's just pick this one. Now, we can have a standalone unit, which has all the controls on it, or just a simple on-off unit. I'm going to take an external signal, because I want to show you how you can pick a LAN or a Modbus, LAN or a BACnet. So now, here are your model numbers, the quantities that you have, the 10-foot of steam hose. If you want to price in a spare cylinder, you can do that. And here is where you take your network. If I wanted to have BACnet on it, I can do that, and it's going to come back here in a second. And now you see the BACnet board on there. There's also some other optional accessories. You can add those on if you want to, but this one you can save, you can print, and you can send it to your TEC representative.
Now, another thing David mentioned earlier, both when he discussed the gas unit and also the resistive element unit, is that both of them come with options of drain tempering. Drain tempering comes with this unit as well, but the reason you don't see it show up as an option down below is with the the Humisteam, the electrode unit, the drain tempering is built in, so there is no additional cost. So it's an added feature of this particular product.
Okay, before I move on, let me see if there's any questions here. All right, some of the other things on this Humidify now, I'm just going to go to the home screen. You can look for literature. You can have a catalog sent to you. There's some other things in here that the representatives can have. If you're just signing in as a guest, you can do just a load calculator, and then any one of these down here goes back into that build a humidifier for me. And this you can configure some
Ultimate Sam.
The short absorption modules, right? If you want some cross-references for Armstrong, Carnes, dry steam, you can do that right up here if you're not familiar, so you can cross-reference it and you can specify one of the Carel models.
Correct.
Okay, we were online. Applications to look for. Basically any applications from woodworking where you don't want your materials to crack, to printing like I talked about before, clean rooms, museums, anything that needs humidity. Hot yoga places. We're seeing quite a bit of these hot yoga places that have a lot of high humidity and 105-degree temperature. So it's becoming very popular. Steam rooms, health clubs, humidors are all becoming very popular. Just some applications to look for. For comfort applications, the Humisteam or compact steam. Compact steam is more of a room humidifier. We didn't go into that today, but they do have a more of a room standalone humidifier.
For light commercial applications and residential applications, it comes in 5, 12, and 20-pound cabinet, and again can be done directly into a duct or directly into a room. It's since it's a lot smaller cabinet, it gives a lot cleaner look, and for the room applications, the blower pack would be built into the unit itself and gives a nice clean finish for an office application or even a small home.
For residential or commercial, you can see that the Ultimate Steam, the short absorption module for comfort, is good with that. You move on to process applications, and you have the Heatersteam with the electrodes, or the gas steam, which is a higher capacity. The Heatersteam is more precise in its control, or the gas steam, which is higher capacity.
Right.
You can have industry storage. Again, you can have any one of the three. And steam baths, you can have any one of the three, just depending on how much humidity you need. Here are their websites, Humidify Now and Carel USA. My name is David Taylor. There's my phone number, email. If you think up of any questions after we're done, please email them to me. We'll get you an answer just as soon as possible. And also, you'll get a thank you note for attending, and we'll send you out a link that you can go back and review the presentation. So we'll stay on here just a few more seconds. I'll leave this slide up. I don't see any more questions. So we'll leave the slide up for another few minutes in case you're coming back to it. You can write down the contact information for myself. But thank you for attending, and thank you for using the Carel product and TEC.